Quentin students, continuing on and talking about polynomial functions. Today, we're going to graph them by hand. So let's go ahead and go on over here to our current PowerPoint slides here, graphing polynomial functions by hand. Let's see, did I share it? I did. Okay. So let's take f of x equals 4x minus 1 all squared x plus 3. And let's just work through this guy. And I have written him off over here so that we can, first of all, just think about what all these numbers, exponents, and such mean. What does 4x minus 1 all squared mean? That means 4x minus 1 is multiplied times itself 2 times. That's x plus 3. And we can use FOIL to multiply this out. 4x minus 1 times 4x minus 1. Multiply your first terms. You get 16x squared. Outer terms, 4x times negative 1 is going to be negative 4x. Inner terms, negative 1 and 4x is going to be negative 4x. Last terms, negative 1 times negative 1 is positive 1. Still got to multiply it all out by the x plus 3. Let's simplify this. This is going to be 16x squared. Negative 4x and negative 4x is negative 8x plus 1. And I still need to multiply it out by the x plus 3. Remember, everybody gets multiplied by everybody. Everybody in the first times everybody in the last. So the 16x squared needs to be multiplied by the x and the 3. That'll give us 16x cubed. 16 times 3 is 48x squared. Then your second term, negative 8x times the x and the 3, negative 8x squared. Negative 8x times 3 is negative 24x. And then the last term times the x and the 3, so plus x and plus 3. I'm running out of room. And so what does our function equal? 16x cubed, nobody to combine him with. 48x squared minus 8x squared is just going to be positive 40x squared. Minus 24x plus x, that's minus 23x, and plus 3 on the end. All right, a couple things I know right off the bat. X cubed, I'm going to have 3 terms. No. I'm going to be degree 3. And so I'll have at most 2 terms, right? And I have a y-intercept of 3 right here, y-intercept of 3, okay? So a couple things right off the bat I know. For very large values of x, it's just going to be this first term. We act like that. But what about, let's set it equal to 0 and let's find our x-intercept. So let's take our original function and set it equal to 0 and find our x-intercepts. All right, so basically 4x minus 1 could equal 0, but it's multiplicity of 2. So that's 4x equals 1, x equals 1/4, but it's multiplicity of 2. So here, little tiny, real close to 0, 0, but it's only going to touch there. And then x plus 3 could equal 0. And it's going to cross at negative 1, negative 2, negative 3. All right, so I'm thinking I've got something, let's see, positive cubed is going to go up, left to right, cross here, and then it's going to kind of tip back here, but only touch at 1/4 and then go on. Or, you know, it might go up like this and come back down and then touch right there. Okay. All right, let's look at it here in our PowerPoint slides, and you'll see that it does actually go up pretty high here. And then it has a y-intercept of 3, and then it touches at 0.25 or 1/4. Good. All right, the end behavior is going to be that first term when multiplied out. Find your X and your Y intercepts. Determine zeros and multiplicity. And turning points. All of these will help you to get the graph by hand. All right, let's try another one. X plus 1 all squared, X minus 3. All right, if we multiply this guy out, a couple things we already know about him. All right, right off the bat, you know that your zeros are going to be X equal to -1, but that's going to be multiplicity of 3. And X equal to +3, and that's a multiplicity of 1. Those are both odd multiplicities, so it's just going to cross there. Here at -1 and +3. Now, our first term would be X to the 3rd times X. So our first term is going to be X to the 4th. So we have a 4th degree equation at most 3 turning points. Would help us to know the y-intercept. That's going to be the very last constant at the end. So 1 to the 3rd power is 1. 1 times -3 is -3. So our y-intercept is going to be something like this. So we're going to be coming down, crossing here. Maybe we'll make a little something like that. And I think it might go kind of deep and then we'll come back up. I actually don't really know too much of what it does, but what we'll do is look here. Oh, yeah, just kind of went down, but then it actually goes really far down, all the way down to -24. How about using a graphing utility to do these guys? All right, same thing. X to the 4th plus 5.2 x cubed minus 2.312 x squared minus all of this. Pause me, write it down. Pause me, write it down, please. And I'm going to share. I can get this guy. All right, let's look at this thing on our graphing calculator here. All right, ours was, and you were supposed to write this down, and if you didn't get it written down, then go pause it and go write it down and rewrite it. X to the 4th plus 5.2 x to the 3rd. And to get to these higher exponents, I'm using the caret button. Minus 2.312 x squared minus 9.654 x minus 2.335. Oops, 5. And I'm just going to go to the standard window and see what this guy looks like. Number 6 is standard, zoom standard. All right, that's reasonably good because I can see a lot of this. All right, I can see my x-intercepts. I can see my y-intercept. I've got a well, we already know it's 4th degree. And see how it has at most 1, 2, 3 turning points. We can calculate our zeros using the calc function, which is above trace on our graphing calculator. So if I go second calc, I can find number 2, the zeros. Number 2 zeros, but I have to tell it which 0 I'm looking for. So I've got 1, 2, 3, 4 zeros I'm looking for. And it wants to know the left bound. So I want to go a little bit to the left side of this first 0. All right, there I am. Let's see, was that blinking? All right, a little bit to the left of this first 0. So I'm here at -5.3. I'll press enter. Then I got to go a little bit to the right. So really just maybe 1 click. Oh, it's hard to see that, isn't it? If you go 1 click to the right, I think we're already past it. Right bound, enter. And see, so it's got our right little spot here that's going to find it. Guess, yes, please guess, enter again. All right, it calculated the 0 at negative 5.3. And this is y equals negative 1, 10 to the negative 12. That's a 0. It's basically 0. So our x is negative 5.3 here. We have 3 more zeros we could calculate. Let's do one more of them. We don't have to do all of them. Second calc. So let's calculate a 0. Why don't we calculate this next one over here? So I want to get on the left side of that 0. Oh my gosh, I'm having a hard time seeing. There we go. All right, I'm on the left side of that 0. Press enter. And now I'm going to go to the right side of that 0. I think I am, but I'm going to go up a little bit more now to the right side of that 0. And then it's going to say guess. Yes, please guess. All right, that 0 is negative 1.1 if I round to the nearest tenth. The x value is negative 1.1. You could also do the same to find the 0 there and that one. Let's say that this was hard for you to see. You can zoom a little bit in. So it looks like this x value is maybe negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So maybe if I made my window not negative 10 to 10, but negative 7 to 7, I might be able to see it a little bit better. Okay. So you can zoom in a little bit, maybe just make your window from negative 7 to positive 7. Now we also want to find this y-intercept here. So let's go back to second calc and not intersect, not value, not max, not the derivative. All right, let's do a value. The value will be when x is 0. When x is 0, what's our y value? It is negative 2.335. The y-intercept is negative 2.335. And you know what? That was very obvious. You didn't even need to do that because that was the constant at the end. The constant at the end, when multiplied out fully, is your y-intercept. Okay? Right, Teddy. Anything else we need to do here? No, I think that's it. All right, Tay. Well, we've done a lot, and your keyword now is turning point. Your keyword for 3.2 is turning points. All right, we'll see you later.